Good afternoon, everyone. My name is Monica, working as assistant professor in CSE AIML department, and I'm working at G. Pullareddy Engineering College, Kurnool. So today I would like to discuss on the topic that is use cases and quantum future. So coming to the first slide, so where this topic emphasizes on the applications of quantum computing and how this quantum technology will be leading for the next era. So, if at all we see the first slide, quantum computing transforming our future, exploring the real world applications where quantum technology is revolutionizing how we solve complex problems and optimize systems. One of the first applications of quantum computers will be in the field of material science and chemistry. So we can see a huge potential in areas leading to cleaner fuel, emission reduction, and energy efficiency also. So in this unit, we will be discussing about all the applications which are related to the quantum future and how the quantum technology is implemented in all these particular applications. So coming to the first application, that is the material science and chemistry. So this is the first application of quantum computers which is used in the field of chemistry and also the material science. We see a huge potential in areas leading to cleaner fuel, emission reduction, and energy efficiency. So, the main advantage of using the quantum in the future, so which is to lead emission reduction and also utilize the energy efficiently and in order and also to implement the cleaner fuel. And the next application is about designing the better catalysts. An important area of research for the energy industry is to develop new methods for converting and optimizing alternative energy sources. So catalyst is nothing but it is a key technology in achieving this goal and impact applications as varied as converting CO2 into usable fuel sources or improving catalytic converters and also the scrubbers to help keep sulfur dioxide out of the atmosphere. So designing catalysts and predicting their reactions, it requires highly accurate calculations of energy and also the differences of molecules. For many transition metal compounds, this is difficult, if not impossible, with the today's classical computing, even running on the world's fastest supercomputer. Because quantum physics, it governs the interactions between atoms. The quantum computing is uniquely suited to simulate and predict which materials will act as good catalysts for a chemical reaction. So the challenge is that classical computers struggle with complex atomic interactions which are needed for the catalytic design. Whereas the quantum, it supports the quantum computers, they naturally simulate the atomic behavior using quantum physics and also the principles. So we usually use catalysts, for example, for converting the CO2 to fuel and also the cleaner industrial processes. So this is also one application of the quantum future. The next slide is about the real world catalytic applications. So we have the catalytic converters, the body enzymes, and also the industrial production. So in the catalytic converters, platinum based catalysts which convert the harmful CO and NO2 gases into safer carbon dioxide and nitrogen in car exhaust systems. In the body enzymes, amylase enzyme in saliva, which is used to break down starch into sugars, speeding up the digestion naturally. Industrial production. Iron catalysts in the Haber process create ammonia for fertilizers that feed the world. So this ammonia, it acts as the natural fertilizer, and also the iron. So these are used as fertilizers which feed the world. And next application is high temperature superconductors. So power grids currently lose approximately 5 to 20% of the energy during transmission and distribution as electricity travels through the materials in the grid. So that's a tremendous amount of wasted money and resources. So superconductors are materials that transport electric charge without any resistance. Most of these materials require cooling to very low temperatures to function. More practical, room temperature superconductors, they could be used the world's energy system, but this class of superconductors is not yet fully understood at the microscopic level. Where the quantum computing, it promises because of its potential to accurately and natively simulate the underlying physics of these complex systems and help scientists to design new materials with the desired properties. So superconductors, they are nothing but they carry the electricity with no energy loss. So imagine current flowing forever without a battery. So by using the normal wires, that is the copper wires, where 5 to 20% of electricity we lose. So superconductors lose zero energy, and this application can be implemented by using the quantum computing technology. So this can also be applied as one application for the quantum future. So we also have some real-time superconductors which are currently in action, the maglev trains, the MRI machines, and also the particle accelerators. So all of them, they act as superconductors where no energy is lost. So this maglev trains is nothing but the magnetic levitation enables speeds over 600 km per hour with zero friction in Japan and China. So this Japan and China, the countries, they usually use this kind of trains, so which have the superconductors in action, and also MRI machines. The superconducting magnets, they create powerful fields for detailed organ imaging in hospitals. So the superconductors, they are also used in MRI machines also. And the superconductors are also used in particle accelerators. CERN uses superconducting magnets to accelerate particles near light speed for research. So these are all the applications where the superconductors, they are used, or the superconductors that are in action. The next topic is about, the next application is about quantum computing for energy optimization. So here we can see Dubai Electricity and Water Authority is working with Microsoft to develop new quantum solutions to address energy optimization and other challenges where classical computers they cannot do. So Dubai 10x vision is that making Dubai country 10 years ahead of other cities through quantum powered energy optimization. So this DEWA partners, it is nothing but Dubai Electricity and Water Authority. So this Dubai Electricity and Water Authority, it is working with Microsoft to balance solar energy, wind energy, and gas sources in the real time. So which uses different quantum tools like Azure Quantum Inspired Services, Quantum Development Kit, and the seamless migration to full quantum. So where the classical computers, they won't focus on these kind of the application, but whereas the quantum computers, they provide solutions to address the energy optimization and other challenges where the classical computers have limitations. So this Dubai 10x is nothing but it is an initiative to use advances in technology to deliver new or existing services in different ways. So, where they can reimagine its role as a utility company by launching Digital Deva. So, this DEWA, it stands for Dubai Electricity and also the Water Authority. So, it is the digital arm of Dubai Electricity and Water Authority and is partnered with Microsoft Quantum to help accelerate its goals. So it is also working closely with Microsoft to develop the quantum strategy, including understanding where quantum optimization methods can be applied for greatest impact in Dubai, both on the classical computers and in the future on Microsoft quantum computers also. Energy optimization, for example, so energy optimization, for example, requires far too much traditional computing power to identify the ideal balance of resources from different energy sources to meet ever-changing consumption needs in a real time. So this Dubai Electricity and Water Authority, it is nothing but it will be able to program and test different quantum algorithms, then apply those quantum solutions with the existing Azure platform to achieve the real world impact even before the development of a general purpose quantum computer. So it also includes the different quantum tools like Azure Quantum Inspired Services, Quantum Development Kit, and the seamless migration to full quantum. The next application is about the traffic flow optimization. So which is nothing but coordinating traffic signals in a large city is usually a complex task. So doing so in a way that minimizes the possibility of the traffic jams and optimizes overall traffic flow in almost impossible tasks using the conventional computing methods. So the old method is that which is called as the local control. So where each light decides independently, causing the city-wide jams. Where the quantum computing, it provides a solution, and that is what we call it as quantum solution. Toyota plus University of Tokyo used D-Wave to coordinate entire 50 by 50 city grid. So they began Toyota researchers, they began by designing a simplified city diagram which is consisting of 50 by 50 grid in which streets can run either east, west or north or south. So as a car approaches a four-way intersection, it has a certain probability of turning right, left or continuing straight on. To minimize congestion and the amount of time each car spends sitting unmoving at the red light. So the researchers here needed to determine which intersection should be green, that is north or south, and which should be green, that is east or west, at any given time. So these signals are needed to respond quickly to changing patterns as traffic moves through the grid. So the results of the work show that D-Wave system responds best to changing the traffic conditions. So the results are less congestion is there, faster responses are provided, and smoother traffic flow, which is there under all different conditions. So this is one of the quantum solution which has been applied for the traffic flow optimization application. The next slide is about the encryption crisis. Quantum computers will break RSA encryption that protects banking, passwords, and government secrets. So if at all we are communicating at state level secrets, we should probably be and probably already are making sure that our encryption is quantum ready, because the quantum computers have been proven to break the most common encryption algorithms such as the public key cryptographic system, that is Rivers-Shamir and Edelman, that is RSA. So this problem can be solved easily by change of cryptography algorithms and with all the investments with uncertain rewards. However, the quantum computer with sufficient power, it can break RSA and does not publish its findings. So if we are communicating at the state level secrets, so we should probably be, and we should also be aware of making sure that our encryption is quantum ready. They are already the quantum encryption algorithms which rely on different problems other than the integer factorization, such as lattice-based crypto systems. So quantum cryptography is like to provide the quantum ready encryption algorithms as well. So at Microsoft, a team is actually working on post-quantum cryptography, and this aims to determine how specific information and communications are made when powerful quantum computers are achieved. And this post-quantum security solutions, it is also used in lattice-based cryptography, McEllis crypto system, and also the quantum cryptography. So in lattice-based cryptography, mathematical structures that remain secure against the quantum attacks. And McEllis crypto system, where the error correcting codes that quantum computers cannot easily break. In the quantum cryptography, using of the quantum physics itself to create unbreakable communication channels. So all these are the applications of the quantum future. So the quantum future awaits the clean energy, innovation, the smart cities, and also the quantum security. So for the clean energy, we use or we design or develop the better catalysts and the and also we use the superconductors where the zero waste of the power systems is done. And it is also used in the quantum computing. It is also used in the applications like innovation, where we can solve different problems where the classical computers find it impossible to solve the problem. We also use the quantum computing in smart cities, that is for the optimized traffic, energy grids, and also the resource management. And last one is about the quantum security. So we use the quantum encryption methods, which are unbreakable encryption protecting our digital future. Thank you.